Okay, so now I'd like to try to draw together some of the things that we've learned, at least for lists, and apply it in a practical application. If you look at this function, which is basically the solution to 3.1, you'll see that we're using a count and a sum and then also an average value to indicate what's in the data that's been selected. Calling my function with the name of the file, fftiny, and the year that I want, and then it's using that to, if the year is correct, add a current value to a sum or a count to a count, and get at the end a count, a sum, and an average of values from this file. Of course, this means that I can also, because it's a function, pass it a different file name and have it work with another file. For this, however, what I want to emphasize is that using a list instead of a float sum and a count, using a list will give us all of the same advantages that using a float sum and a count have given us, but in addition will allow us to do even more sophisticated analysis. In this solution, what we would do is take the list, initialize an empty list rather, before we begin. And then instead of adding to the values that we have, we are simply going to append the current value to the list. By the end, and I'll just forget about the returns right now, I'll just return 0, 0, 0, but what I really want to see is this list and see what's in this list. Well, maybe I'll just return the list and then change my calling code to match. Now, when we print the collected values, we're going to see that we have the same advantages that we do, or we have the same types of analysis we can do with a list that we could do with a float or a sum. For example, what if I told you, once we had appended, and again, just to go over this code again, we're taking the list, the empty list, before we begin looping. And then while we're looping, we append each value to the list, and then finally return the list. This is why you're seeing the list values here. But here's the question. Given that we have a collected list of values, can you see a way for us to get the count, sum, and average from this list? And if I were you, I would pause this video and make sure that you do understand it, and then you can check your understanding against the answer when you unpause. Okay, so the answer is we can use those same summary functions that we've talked about. We can get the sum, we can get the count, and we can get the average. So we can say something like print the sum of collected values, I chose a long name there, divided by the len of collected values. Len, of course, will get us the count, which is the same as if we had done an integer count. Sum will get us the sum of values, and if we divide the len into the sum, we'll get the average. But in addition to that, we should be able to do a lot of other really interesting things with this list, because when we look at the list, you can see that it has an order. That's something that's important. There are other things we can do with that list that might make it interesting. For example, we could sort the values and get just the top 3. We could get the top or bottom using max and min. We probably should stick with that. That's the easiest way to do that. But with a sorted list, if we were to sort the list, this gives us the opportunity to talk about ranking rather than just the greatest value or just the sum or the average. If we have the values, and why don't I just reverse this sort? If we have the values in a reverse order, I can easily say what were the top 2. And if I had a longer list, I could get the top 3 or the top 5. We could also get something called the median. And the median is something that I'll want you to try to calculate. This is a little bit of a logic puzzle, but how could I get the median value out of any list? If the list has 3 values or 5 values or 7 values or 9 values, how could I get the median value? We could ask that question. Well, let's just use a different. I think if I use 1927, I'll get a couple more values. No, there's only 4 there. So 2 values there. So I think I'm going to stick with my 1928. How would I get the median of a list of sorted values? Well, you're going to need to pick the middle value. The median is the middle value. It's sort of like a traffic median, right? It's the thing that runs down the middle. So the middle value is the median. And that's an important facet of statistical analysis, being able to determine the median. How could we get the median in this case? Well, we'd need to be able to say where the middle value was. Obviously, looking at this list, we know that the middle value is an integer. Is the value 1. But if we had a longer value, if I made collected values into something else, maybe I'd like to give it some additional values. If we look at that sorted list of values, how can we get the median out of this? Well, we'd have to choose the middle. Oh, I was better with the other one. Let's do that. We'd have to choose the middle value, and the middle value is going to be, gosh darn it, guess I was wrong. I'm not often wrong, but when I am, I am. There's the middle value, 0.12. If that's the middle value, how could we determine that this is the one? We'd have to do it by first sorting the values so that we can see which one is the middle. Then we'd have to use an index to indicate where the middle value is. What is the index of 0.12? It's 3, right? The 4th item in the list, 3. Now the question becomes, how can we determine the middle index on any list? And the answer is, we would get the length, divide by 2, and convert to integer. So this would be one way to get the median. Get the length, divide by 2, and then convert to int. Why do we need to convert to int? Well, let's look at this one. How would we get the 3 index out of a list of 7 items? The answer is you divide by 2. That gets you 3.5. 3.5 is not helpful as an index. So if we convert to int, we'll end up getting 3. And if we have 3, that's the middle index. Now, getting the median is a little more complex when we're working with an even number of items. In an even number of items, we're going to need to grab the middle 2 and average them. So it's going to be similar. You would get the middle 2 values and then get the average between those 2, and that would get you the median on an even number of values. The question then is, if you're looking at any given list of even or odd numbers of values, how can you determine whether or not to get the median by using the simple index that represents half the length divided by 2 and converted to int, or to get the 2 values and average them? And you'd need to know whether or not the number of items in the list was even or odd. Do you remember how to do that? Use the modulus operator. Check out the modulus slide to see how to do that. Now, I've really gone over this getting the median very, very briefly. We're going to go over it again in class, but I wanted to just give you a sense of why it's important and how we would compile a list of values from a data source.